enormous amounts of carbon as we currently are, and sustainability is frankly an essential element that we all have to be seriously considering. Glass Futures is set up by the glass industry together, as I said before, with substantial government funding to research into the practical use of alternative energy sources. And we're building 160,000 square foot research and development innovation center in St. Helens, which you will hear about, with a 30 ton per day furnace as the integral central part. And this furnace is designed to be everything to everybody on all fuels that we can fire instead of natural gas. And again, Aston and his team will be explaining in much greater detail the type of thing that we're talking about, but particularly targeting on the immediate future and why you should all be very, very interested to get more closely involved with Glass Futures. Anyway, at this juncture, can I hand across to you, Aston? Aston Fuller, who is our general manager, will take you through the fun section 1 of the proceedings. Over to you, Aston.
Thank you very much, Richard. And just a big thanks from my side for everyone coming together. Understand that it's obviously quite a lot of Zoom meetings that everyone's used to nowadays and Teams meetings. So what we have attempted to do throughout this session is to provide information so people can learn a bit more about what we do, but also begin to open the conversation to the wider industry overall. So as an agenda, I'll go through a bit of an introduction and some important information. I'll give a brief overview of Glass Futures for those that may not be familiar with who we are and what we do. An overview of the St. Helens pilot plant, which is the innovation centre we're putting together and the plant that we're designing. And then we're going to run through a few important sections. This is obviously one of 3 sessions where we're looking to cover some content on raw materials, melting and furnace technology, and then refractories as well, with a short Q&A session in between, just to, I suppose, open the conversation up and allow people to think about the ways in which they can potentially provide input or ask questions about the way that we go forward. So some important information overall. This is a really critical piece of legislation around the way that Glass Futures operates. We are working collaboratively across the glass industry with competitors. And for us, antitrust and competition law is very important. This is not a forum in any way to discuss any commercially sensitive information for any manufacturers or supply chain partners. And as such, any commercial information exchange will actually cause a meeting to come to an end. And we are recording this session to ensure that we have a clear record of what was discussed and what went out into the public and any comments that everyone else made. So from confidentiality perspective, this is a public event, so please do not share any confidential information at the session that you consider confidential. This is a public event that a recording will be made available to people in the future as well. Obviously, from a terminology perspective, the glass industry's got very specific terminology, even between different sectors or different plants across the glass industry. Furnaces have different names for different pieces, and very similar equipment can have different names. If there is anything you don't understand from a technical perspective, just drop a question down in the chat box, and in the background we'll try and help answer it, just as there's anything you don't understand. But there is going to be some technical terminology. We can't get away from it. It's what we do. And as we've said before, everyone's muted currently. So during the Q&A portions, please feel free to type your question, raise your hand, and if you're invited to ask the question, please then you can unmute yourself and ask the question directly. So I wanted to provide a summary for Glass Futures overall, and obviously at sessions like this, I'm aware of the fact that people have different levels of knowledge and understanding of who we are and what we do. I think ultimately an important message to get across is that Glass Futures is co-creating, which is an important word throughout this process, the global centre of excellence to really help make glass a low carbon material of choice and ultimately to increase its use throughout society. What Glass Futures does as an organisation is work both privately and collaboratively across our membership to help transform research into reality. We really want to demonstrate new technology And the demonstration point is a really important aspect of what we do. This is not just about research, but this is really about development and demonstration. We really want to drive commercial thinking into research. Too often research is carried out for academic endeavour and educational purposes, whereas the reality is that we're here to serve the glass industry and the glass supply chain. And the glass supply chain requires that research, but what it also requires is demonstrable, commercially viable technologies to help transform their business models. So ultimately, we believe that this can lead to a low-cost pathway to change across the glass sector. Change needs to happen. I think everyone acknowledges that. The reality is change has to happen in an economically viable fashion. So to empower us to do this, we've got some very strong values. We really think it's important that our approach, so we are a research and technology organisation. So we are a not-for-profit, non-commercial organisation. We are not a manufacturer of glass products to sell into the marketplace. We aim to manufacture knowledge on behalf of our members overall. And our members, anyone is allowed to be a member. We have a transparent membership process where information is available on request. And we do have an open and fair access policy. We really think that being inclusive is important throughout this process, and that partnership is an important aspect of what we do. However, what we must recognise is that the industry is competitive, and some technologies and some developments aren't public knowledge and they aren't to be shared. So it's really important for us from a value perspective that we have a respect for confidentiality, and both of our internal information, but also our information in relation to our members. Because the reality is what we're trying to do here is to drive technology forwards to allow the industry to improve, but also to ensure that we still have good competition within the industry, because we know that competition in the marketplace is an important aspect of any good and functioning society. So ultimately, this is all about us generating intellectual property for our members, be that in a private or in a collaborative fashion across our membership group, or in small individual projects for our members. Glass Futures is designed and built on behalf of the glass industry, who we see as our members, and this really is about serving the needs of our members all overall. So an important part of the approach that we've taken is very closely aligned with the UN's Sustainable Development Goals, which were put together in 2015. Set of 17 goals that were laid out, agreed across the United Nations as important aspects for how we actually push sustainable development and sustainable change. So there's a number that I believe as Glass Futures we tap into very well. In particular, number 17 is partnerships for the goals. And I've personally seen this a lot over the course of the past 2 years. And I think we're seeing it more and more often, especially when you look at the current global climate, is that partnership and collaboration is actually pivotal to allowing us to overcome some of our deepest, most challenging issues as a society, and to actually come forward and help promote change that gives sustainability in many different areas. For the glass industry in particular, glass is a ubiquitous material. So I've named a number of what are considered the key manufacturing sectors of glass overall. So the container industry, generally serving into the food and drinks market, the perfumery market, the float industry, which serves into construction, but also automotive. Ultra thin glasses, speciality glasses are used in electronics, very high value products, aerospace industry. You've then got fiber, which is in relation to both building products, but also communications. It's all around us. It's everywhere. It's everywhere in society, and it really is considered a material that has allowed civilization to thrive. And we believe that will continue for many years to come. The interesting part about the glass industry in particular, and I think where Glass Futures has found a very positive home and approach, is that there are many different sectors across the glass industry that serve different markets. And as such, they haven't always communicated and collaborated effectively as industries that have very common problems. If you look at the float industry and the container industry as an example, the melting processes involved and the key capital assets required to manufacture glass in the first instance are very similar. However, the manufacturing process is different. The markets they serve is very different. And as such, they haven't always collaborated on some of these aspects where there are a common interest. And the role of Glass Futures really is to pull those different sectors together and to find those common interests to allow us to increase sustainability and collaboration in the glass industry overall. So in terms of what Glass Futures does, and obviously what we're here today to talk about is the pilot plant that we are currently designing and in the process of building in St Helens. What's important to point out is that this is not just what Glass Futures is about, a pilot plant. As you might imagine, what's important when you have such an asset and a plant overall is that you've got a pipeline of projects, technology themes that you're really focusing on to help drive an industry forward. So, and these slides will be shared afterwards, so I won't go through everything in too much detail, but what we wanted to do here is just to show a wide range of the many different areas in which Glass Futures aims to help drive the industry forwards. And there's a significant investment being made, as Richard alluded to, by the UKRI, which confirmed in October of last year a £50 million investment towards the capital build of the pilot plant itself. There's a significant investment being made by the Liverpool City region, by St Helens Local Borough Council, all of which is coming together to form a very significant part that allows this once in a lifetime experience to actually come into fruition. This is also being backed by significant private investment across the industry and with a huge amount of input, not just in terms of materials and potential future resources, but also in terms of the time that the industry has actually spent on pushing this forward overall. We do say that we're working across the supply chain, and I think what is very evident in some of the projects we're currently involved in outside of the pilot plant is that they really do span academia and industry. We see our primary role as really bridging the gap between academia and industry. As an example, throughout this process of actually putting together the pilot plant, we have held a significant amount of design sessions over the course of the last year, where a number of our members have put forward some of sorry, my headphones tried to turn themselves off. Where a number of our members have put forward a significant amount of technical expertise and time in helping us pull together what are our preliminary designs for the whole facility. A number of those people are on the call today, and I will invite them to speak and answer some questions as we go throughout the session. So in terms of the current projects that we're really looking at, and what you'll see through this presentation is that these tie in to the design and the development of the facility. So when we are fully operational and fully commissioned, is that these projects that we're currently working on will actually feed into the pipeline of work that we do at St Helens. So really the key cornerstone of the work that we've been carrying out over the course of the past year is our industrial fuel switching project. This is a £7 million programme funded by BEIS, which is a UK government body, to look at the way in which we decarbonise the glass industry and the way in which we use alternative fuels. So this is looking at hydrogen, biofuels, electric melting, key questions that we know at the forefront of industrial change, not just for the glass industry, but for the wider industries that use very similar high temperature processes as well. There's a number of other projects we're involved in currently that are really feeding into our longer term pipeline. In particular, I was looking at new raw materials from waste heat recovery technologies, the manufacture of green hydrogen, but also furnace efficiency and NOx emissions developments, especially around burners as well. So what we recognise the facility will enable is a unique training facility. And I think that will become very evident as we go through this process and we begin to understand that we're not building an operational production facility, we're building a research and development facility that gives us the ability to actually provide hands-on training and unique experiences that are in an environment that looks and feels like a glass industry, looks and feels like a glass manufacturing plant, but is in and of itself not constrained by those same production pressures that exist in the glass industry. So what we have here in terms of our opportunities is a list of what we see as our key common themes. I said this will be shared overall and we'll discuss a number of these throughout the presentation, so I won't go through them one by one. So to give people an overview of the St Helens pilot plant development, what's important is that over the course of this process, we are co-designing this not just as a Glass Futures internal team, but also utilising the resources, the technical expertise of our members, who are heavily involved in a number of extensive design sessions, but also the idea to actually open this out to the wider industry in a session like this is to actually ensure that we get best knowledge and that we build something that is truly built to serve the industry upon which it is based. So the facility itself will open in 2023. Over the course of the next 2 years, as you might imagine, with a facility and installation like this and the complexity of such a place, there's a lot of work to do around the design and specification that really are being decided and detailed out over the course of this next year. So, you know, from a lead-in time perspective, From a building and commission perspective, there's a lot of activity going on at the moment to bring this to reality in 2023. So we are building a 30-ton per day glass melting capability, which has got a fully functioning batch plant. So anyone that's in a glass plant, I think, will undoubtedly recognise the building that will be seen as the batch plant on the side of that development up there. We currently plan on accommodating an IS container forming machine, so we can run production trials and machine developments and hot end developments. What we're also looking at is space accommodation for a rolled plate line to allow us to produce flat and sheet glass as well. So we've got both capabilities covered to try and really pull together industries that typically have very separate processes. We really see this as an opportunity to have an integrated Industry 4.0 approach. It is imperative that we build this into the fabric of the facility from day one and allow this to really demonstrate the introduction of new technology to industry. That demonstration space is vitally important. What we recognise is that the industry is served by its supply chain, and manufacturers more often than not rely on their supply chain to provide them with solutions and technology developments. What we want to be able to offer at this facility is a place for a supply chain to come and demonstrate and to come and develop their equipment as well, and allow them to actually show it in a working environment so the industry can actually adopt that technology. This facility will allow for significant amounts of training, and as we've gone through the design process, we've really thought about the way that this building will interact with not only its traditional operators, but also people that are coming in to learn about what we do and coming in to train on new equipment or to carry out procedures that typically are only ever done in emergencies in glass plants, but in a way that we can actually design those processes and training capabilities in. Total investment value for the facility is in the region of £54 million. This really is a significant asset. And this is not designed as a UK-based asset. This is a global asset in the United Kingdom enabled by a UK government investment, but this really is about serving a global industry. What we do also recognise from that global industry is that some of the research and development we do here is also going to be relevant to other similar industries, people that have high temperature processes, people that use refractories, people that use Industry 4 and automation technologies. This is going to be a hotbed of developments that will also spill out into other industries, and we can also pull developments from other industries into ours as well. So I will talk a bit about HyNet as we go through the refractory piece in particular, but the location for this facility, for those that are or aren't aware, with St Helens, which is in the Liverpool City region, just north of Liverpool, is that there's a stadium just in the top left-hand corner of that picture in the top right, which is the totally wicked St Helens football rugby ground. And you can see here that this is part of a larger plot. And the reason we've mentioned this HyNet proximity is the region is currently looking at a deployed hydrogen network in about 2027. And we're in a very prime location to be placed to actually tap into that high volume of supply of hydrogen overall. So I'm going to take just a very short break there overall and just see if there's any questions from across the group about the introduction so far, or anything that comes up. Just take a look. None so far. I'll just wait 1 minute. Conscious that I tend to talk quite a bit in these, so Matthew, I see you've got your hand up, so we'll ask you first.
I was just going to ask, your 30-tonne a day figure, 30 tonnes a day is a different size furnace for flat or for container. So I'm intrigued that you refer to it by tonnage rather than by capacity. I just wondered what you've got to, what's your 30 tonnes a day based on?
Good question, and I will let Richard Hume come in on this as well. It's a figure that's nominally there because there's many different ways that you can measure furnace output. So tons per square meter. What's the pull rate? What's the size of the furnace? How much do you plan on pulling it? In reality, I think the overall output of that furnace probably ranges from 15 to 50, depending on how long you want it to last and how you want to actually utilize it. So we've picked that as what is seen as a nominal figure, so at least we've got a figure to stick to try and sort of increase clarity overall. I don't know, Richard, in terms of the container and float differences, if you want to offer any comment on that.
Yeah, thank you, Aston. Thanks for the question, Matthew. I'm sure people are going to ask, why is Guardian interested in a 30-ton-a-day container furnace at some point anyway? Well, we're basing this furnace on 1.5 tons a square metre. We don't expect to be making float quality glass on this particular furnace, but it will provide a route to doing some of the experiments that we can't do on our float furnaces, and I can come on to that in a little bit. I will say, to challenge what Richard Katz said to start with, he said it's going to be everything to everybody. It's not. It won't be. We understand the limitations relative to our particular process, but what I would urge people on the call is, if you have something that is particularly important to you in a pilot plant, now is the time to get involved with Glass Futures. Otherwise, for the first campaign, you will get what we will build. Right now, we know it's going to be a throated furnace. It's going to be 1.5 tons a square metre. That's okay for the experiments we've got designed, Matthew. There are differences, but yeah, it'll be okay. Is that all right, Aston? You okay with that?
That's perfect. Thank you. Rene, would you like to ask a question?
Yeah, hello. Good afternoon. Yeah, you mentioned that you have most probably sufficient hydrogen supply to that facility, but would you also have sufficient electrical supply to that facility to, if you would choose it, to run those furnaces also in an all-electric way?
Yeah. So one of the key things that we've looked at from a specification perspective, and I'll talk about the challenges for the furnace design shortly, but in terms of that early supplies and utilities onto the plant, we have enough to run at a 30 ton per day at 100% electric. We don't envisage that we'll be doing it very often, but that is one of the things that we did, was to make sure that we had that supply onto site from an electricity use perspective. So it is available, as you might imagine, depending on the growth rate of the facility and the experiments within it. At some point, it will, there will be increased costs to actually install significantly further upgrades. What we have done at the moment is identified the costs and outlooks for a significant electrical infrastructure upgrade as well. So,
and I think, Aston, it's fair to say that Scottish Power do have the facility of bringing a lot more to that site, and we do have space to accommodate more power, right?
Yeah, no, that's correct. Everything has a cost.
Okay, yeah, of course. Thank you.
Okay, thank you, Ronnie. Okay, I'll proceed on then. So to discuss some raw materials, I wanted to give people an overview of where we are in the process and what our thoughts are in this area. So in December of this year, we appointed EME to actually bring us a design for a suitable batch plant, with a view that we will actually be procuring a main contractor in Q2 of this year. So to give people an understanding of that process, over the course of the past year, the design team internally put together some basic design specifications to say what would be needed of a batch plant overall. We've then brought a designer on board to actually bring that into a design and a specification that allows us to go into the marketplace with a specified design to say, this is exactly what we want. How much is this going to cost to actually build and install? So interesting throughout this process. What we do need, even though this is a research and development, well, in particular because this is a research and development facility, is we need an industrial standard of a batch plant. As any batch plant user knows, as any manufacturer will know, if you have problems in the batch plant, the rest of the facility stops. So the interesting thing that we went through when looking at our initial batch plant concepts and designs is we're slightly opposed, and it's unique in a way as a facility because this is a research program, and this is looking at the ability to trial a flexible range of raw materials and compositions. So even though we need flexibility from a batch plant, what we also need is the reliability aspect. And you'll see this as evident throughout the furnace specifications. When you're designing a research and development platform, what you're not doing is designing a production facility. And we used a common phrase inside the design session meetings, and sometimes we revert, but the phrase that we've used a lot is to take your production hat off. And what's interesting is once you start to think about a glass melting facility without the same production pressure of 98% yields must be achieved 24 hours a day, 365 days a year, it starts to open the imagination up to think, what can you actually trial on a furnace like this? What can you actually put forward that you would never do on a real furnace, or you would never do in a real batch plant? Now, that thought process has been different throughout this entire design process. Some areas in particular give us a lot more freedom and a lot more options. But one of the things that we wanted to do with the batch plant was to make sure that it was capable of running 0% to 100% cullet. And Matthew, I think your question around the 30 ton per day was particularly poignant, because in looking at the furnace specification, we're focusing for a 30 ton per day furnace. The reality is you could put 50 tons a day through it if you so wished. So when looking at the specification for the batch plant, again, we had the same issue of, we do want to run some very high cullet experiments. We think that's an important progression for the industry, and to have a platform where you can try very high cullet percentages with slightly different additions is a brilliant opportunity. But on the same merit, there is particularly some interesting raw materials that you may wish to reduce the variability from cullet, and so you might run at a very low cullet percentage. So in a very dissimilar fashion to the real industry, is that ultimately our specification for the batch plant is we need it to be as consistent as a real industrial batch plant, and it has to look and feel like an industrial plant. However, we have a very wide operating range, not just for the batch and the cullet amounts that we put in, but also for the amount of raw materials that we want to use. We will not produce one single type of glass and one single glass composition, and we will look to trial new raw materials on the facility. As such, we have to have spare silos. How many spare silos is enough? How easy is it to clean silos out on a batch plant? And if you aren't using the materials regularly because you're running at a high cullet percentage, how do you ensure that the batch plant doesn't have materials that cake up? So there's been some very unique design challenges around the batch plant. I do think it's an area where I've seen the design group internal to Glass Futures really explore a number of different options and then hone in on something that works for us, because what we need is consistency, and we need a real batch plant. But what this does do is give us a good development platform. Typically the batch plant is an area where it doesn't always get a lot of love and attention. It doesn't always get a huge amount of investment from the industry, and it just performs in the background and does the job it's asked to do. As such, we think there's a number of different development opportunities in relation to raw materials in the batch plant overall. In particular, there's a huge amount of interest in new raw materials. So this is about not just raw materials being used from different sources. There may be different grades or different qualities that the industry's never used before, and as such it's risk averse, but also the secondary raw materials areas in particular. So there's I'll discuss this in a second, so I'll leave that 1 minute. But carbonate free materials we know are of great interest overall to the industry. What we recognize is that by having this development platform, we can reduce the risk to any manufacturer and also any raw material supplier to actually come and demonstrably prove the efficacy of that raw material in a proper glass melting process without having to risk 200 tons a day or 1,000 tons a day of anyone's actual production manufacturing facility. So secondary raw materials at the moment is hugely important. What's interesting is that often we talk about cullet percentage as our measure of recyclable content, and one of the interesting things that we're starting to see is actually a shift away from just a cullet content, but also a recycled material content. And we recognize that there are a number of materials that are used in the glass sector that are wastes from the steel sector. and cullet obviously as a raw material. Recycling of EP dust is a standard industry practice. What we see is that there's a huge amount of interests as we look across the circular economy piece to identify what secondary raw materials might exist and actually finding a demonstrable way to actually get them into the industry. So we do really want to maximise the use of cullet and cullet handling, and we recognise that cullet is about economics and volume, and more often than not, one of the biggest challenges for very high cullet levels is generally decolorizing in flint, as an example. We have an opportunity within this plant to run small trials and use different raw materials that maybe haven't been used before, and to prove them in a low risk fashion. We really do think that an at-scale test of different grades of raw materials and different raw materials will be a global first. The risk mitigation that we can have by having a facility where we can afford to lose a couple of days of output because it's answering a major question that has a significantly higher value to the rest of the industry is a really positive way for Glass Futures to contribute throughout the supply chain and actually have a very high impact and to remove risk from the industry. So we can have a little Q&A session now, really around raw materials and the batch plant area in particular, if there's any questions or any misunderstandings. I think one of the key questions that I wanted to ask out to people overall as a thought process is what are the opportunities that you think we might have missed in this area, if there is any? And I suppose a larger question to the industry overall is, what experimental materials are there in the pipeline across industry that have essentially come to a development stage and then not been allowed to progress further because there wasn't a way to actually get past that demonstration barrier overall. So, David, I'll see you've got your hand up there. So,
hi, Aston. Just a quick question on the batch. Are you considering preheating any raw materials as part of the batch plant design?
So it's definitely something that's come up in the questions overall and that we've discussed. One of the key things that we have looked at is the ability to accommodate a batch preheater around the furnace. As with anything, what we're currently assessing is the business case aspect of it. So, at what scale do we need or require a piece of equipment such as that? Is there a significant interest in the area to actually prove this on scale? So it's definitely been discussed. It's on part of our sort of specifications as an optional piece to make sure that we assess. We've not gone into it in too much detail as yet, so definitely an area of opportunity, I think, for some sort of new advances and new approaches in that area. So I'm going to go through Animesh.
Hi, Aston. Thank you. Questions. You said from steel sector, there are opportunities to recycle waste. So I assume you are considering blast furnace slag or steel making slag. And steel sector, you have secondary steel making, and then you have integrated steel plant. The slags from the secondary steel making is very different, particularly when you are looking at EAF, electric arc furnace. And when you say low cost raw materials or zero cost raw materials, are there anything else from particularly secondary steel making side, particularly looking at EAF, dust, etc.? Because that's a completely different breed, but has got good chromium content if somebody wants to use the color.
Okay, that's good. I know that particularly the steel sector is well known due to the use of calamite across the whole industry. So, there is that precedent there. We know those advances were a number of years ago overall, but we recognise that this is an opportunity to maybe look at some of those materials that don't have a proven track record. So definitely a big area of interest. I'm going to ask Graham to ask a question, if you could.
Great, thanks. The construction industry is notoriously poor at having construction demolition waste, particularly glass, returned back into the glass making process. And one of those difficulties is dealing with the contaminants that arise from a deconstruction. So I wonder if there's any consideration of looking at how higher levels of contaminants or from that from the waste collection could be dealt with in the furnace to provide a greater variety of waste to be returned.
It's a good question, and Matt's got his hand up. So I mean, even though he's not part of this, he might have to answer it. I think I've done quite a bit of work on it myself in a previous role, and I think poor material in, poor material out. And I'm using the politically correct phrase. I think in particular what we recognise is that the glass industry will not, and I say will not, stand for cementitious or refractory contamination of cullet going into the furnace. So I think it's a big area of opportunity to improve the construction sector. I personally believe those advances will be made on the processing and raw materials processing side. We see an opportunity with the facility at St Helens as a way to actually link in and tie in better with some of those technology developments and help to try and bring them into market at a faster rate overall. So Matt, you had your hand up for a question. I don't know if you want to make a comment before a question.
Well, I will make a quick comment there that I think the issue is mostly commercial. That it's not impossible to decontaminate flat glass to a quality that would be suitable for container glass. Very unlikely to get it back into flat. But the lack of an extended producer responsibility scheme providing any sort of commercial support means that there just isn't enough money in the supply chain to do it. And at the moment, the quantities are not great enough to justify building a plant, and it needs something to change in the way that the recycling of flat glass is paid for. That would, but that could lead to more material being available. There's just not money in it at the moment. My question was about the sort of the outside half of the batch plant. That batch plants always need a cullet yard, so yeah, okay, we do move on to cullet. But I was wondering if what your cullet yard looks like, because you will have production cullet and off cullet and all sorts of weird and wonderful products. And are you privy to show us what that looks like as well?
So we can put some more information in share. I mean, what's not shown on this CGI, I know that's probably a bit small for you there. What's not shown on the CGI is any sort of bay areas. So, I mean, considering the output is in the region of 30 tonnes, I think the overall storage capacity is in the region of a couple of thousand tonnes of cullet. So we've definitely got space and allocations available. That was, if I'm honest, putting together the actual yard design was probably one of the real challenges of the group in the early stages. In particular, how much cullet is too much cullet to store, and for a lot of people there's never enough storage. But on the same merit, we're not building a production facility, so do we need to be keeping a huge amount of cullet storage on site? It's about trying to find the balance. So I think we've got plenty of space. Some people will probably say we have, some people might say we haven't. Rene, I'll take your question and then I'll move on after this section.
Yeah, as to that question, did you also consider pelletizing raw materials?
So in terms of the main design drivers for the batch plant overall, I don't know, I mean, Richard, you're obviously very closely working in this area and closely working with EME. Did you want to sort of discuss the philosophy of, I suppose, picking silo sizes and, for certain deliveries coming in versus stuff being palletized?
Yeah, sure. Thanks, Rene. Yeah, I mean, this is very different to anything Guardian has built, right? I mean, when we build a float line, we know how many silos, what raw materials and everything else. So this batch house has been very wide scoped, and one of the things we did ask for is the ability to to receive and batch pelletized or even briquettes through this system. So if you take it from raw material delivery to the actual doghouse on the furnace, it will be capable of dealing with standard batch, high cullet batch, pelletized batch, briquetted batch.
Okay.
And even a consideration for pneumatic transfer of batch as well, which is something we steer clear of. But yeah.
Okay. Thanks, Richard.
Thank you.
Okay, I'll move on to the next section. Thank you for the question, Benny. So I'll move on to the approach around the furnace, just to give people a flavour overall. So for the batch plant, we have an appointed designer, and we'll look towards a tender process this year. We're currently in the process of tendering for someone to come in and actually take the considerations of the design group, our many different options and variables and our thoughts, and to actually try and distill that into a reasonable design that we can then go out into the marketplace and say, this is the furnace that we want, this is our design, and let's actually build it and put it down on the ground. So here's an overview, and what the astute of you will notice is that we've currently got a 4.5 running into an IS machine. I think in particular, one of the things that we've looked at around the furnace is not just what does this furnace look like on day one, is that actually we're building a research and development platform here. This is not a production platform that will have a machine in a certain location for 20 years. The ability to bring a machine in and out of the facility we think is a really important one. The potential to have a rolled plate line or a second IS machine has to be thought about, because the impact on the building works is vitally important. You cannot go back and retrospectively put civil works in for a 20-ton IS machine. You have to think about it in the early stages. So we've taken that same philosophy when looking at the furnace as well. This is not just about what we think the furnace will look like in the early stage of this process. It's also about what might a furnace look like in this location in 5, 10 and 15 years time. What's the footprint of that furnace going to look like? How much will it weigh? And what's the 3D geometry of a furnace? Is it going to be significantly taller? Will it be longer and thinner? Might it be wider? In fact, it's been a difficult process to really ascertain what are the boundary conditions that we need to think about. And it's not just what do we build on day one, it's what might the industry be building in 15 or 20 years time. And if we knew that, we probably wouldn't be running a not-for-profit because it would probably be a huge opportunity to say, this is what you'll do in 20 years and we're going to do it today. But what we have done is explored the boundaries of how wide might this thing want to be? How long might it want to be? Okay, we don't think it's going to be that big on day one, but let's have civil works planned out so in future we can actually cover different shapes and sizes. We can put additional chambers on in different locations, and we've got that future flexibility built into the plant. We've taken that same approach on the working end and the 4.5 designs as well. So currently planning out a number of different locations and areas and potential layouts that might exist for a 4.5 or a working end design. The taking your production hat off piece has been particularly exciting. I'm formerly a batch and furnace person, so this is my area, and to be in a open conversation with some of the leading batch and furnace experts around the world to actually explore this concept of this does not have to produce 30 tons a day for the next 20 years at a 95% yield. And as soon as you move away from that barrier that is synonymous with any furnace that's built anywhere in the world, you actually start to recognize a lot of significant opportunities that that aren't always very obvious because it's never been done, it's never been thought about before. In particular, the initial campaign length of the furnace has been a matter for much discussion. One of the interesting things that we think about is a furnace that's built today, any particular or typical plant, might well last until 2040 or 2041. Now, to build a furnace that's going to last for 20 years, it obviously removes your ability to innovate on a rapid cycle perspective. To change the design of your furnace, you say, right, we've got a better furnace design, we'll wait 18 years until we put it in. It's not allowing the industry to try these new things relatively regularly and quite often. So as we've gone through this process, the thing we've thought about is what should a campaign length for a research and development platform actually look like? because we believe if we build a furnace and it lasts for 20 years, then we probably aren't innovating or doing too much research and development. And we've probably fallen into the same trap that really currently stunts the industry's ability to actually change and update and innovate on a regular basis. What we do need, in the same way that we have for the batch plant, is stable and repeatable quality. What's vitally important for any research and development platform is being able to prove that our results are not a matter of luck or poor fortune, that the wind was blowing in the right direction on a certain day, but to show that actually the results we've got are because we've got a very stable process that is well understood, that looks and acts in a very similar way to the way that the glass industry currently melts and operates its manufacturing facilities. Given the current membership base and the fact that the global industry produces a huge amount of soda lime silica glasses, this is going to be a soda lime silica furnace. The interesting thing that we have discussed is the campaign length aspect. Typically for a furnace in a manufacturing facility, as you get closer to the end of the furnace's life, you are more conservative because you don't want to lose it. Ironically, for this facility, it actually works in a slightly different way. The older the furnace is, the more that the asset's utilised and the more knowledge we get from it, the more we're able to actually experiment on the boundaries of things that you wouldn't want to do on a brand new furnace that you're putting in as a research and development platform. There may be a big opportunity with this facility when we are aiming to actually end its campaign length to try something radically different for the last week or the last month of its operation, to give us a real opportunity to try some of this blue sky thinking approach. And I think actually that different setup to the industry thinking is going to be important for helping us progress. We will become less risk averse as the furnace ages and not more risk averse, which is currently the trap that the industry falls into. So, and those innovation cycles we think are vitally important to help us drive forward. What we recognise out of Glass Futures is initial campaign and that first lifespan of the furnace, which may be 3 to 5 years, is that we have to help the industry drive towards more rapid innovation and smaller innovation cycles. As we go through this process, we recognise that the industry can see within that 3 to 5 year period that the results that we produce at this facility are of high quality and are highly demonstrable to the industry's need to change. What we cannot build on day one is a furnace that is so radically far removed from what the rest of the industry is used to using. You're not helping to drive change and showing leadership if you're too far away, and people can't see the commonalities between that and your own process. So this has been a very interesting process to think through. How can we help the industry move forward, but not be seen as something that is doing something radically different that no one in the industry understands? And I think finding that balance has been really important for our process of our initial conceptualizing what this thing is going to look like, what its initial capability is going to be. And that's why our current design philosophy has been one of to have a furnace and a process that looks and feels and acts in a very similar way to current manufacturing processes, but then to give us time throughout that period to work out what is something that is actually potentially a radical step change after these first initial proven results campaigns. That's currently the thought process, and that's been born of a wide discussion across industry to understand how can we make sure this yields benefit and results to the industry, but also then allows us to begin to really ramp up the rate of change that the industry is going through. Ultimately, this facility is about proving certain technologies, and I'll discuss those in a second. But what we do recognise is that for the supply chain in particular that produces a lot of the equipment and a lot of the technology that currently goes into the industry, is that more often than not, a supplier might turn up and say, I want to try something very new on your furnace, and it's never been proven anywhere before. As you might imagine, the industry more often than not is being risk averse. Will say, well, show me where it's worked before, and you can come and do it on this facility as well. What we recognise is that we can work with the supply chain on this furnace to help prove and demonstrate some of these technologies. I'm going to have to plug my headphones in as well, so I do apologise. To go through some furnace developments that we've been looking at that are really important, energy sources in particular, low carbon fuels are, a very important topic not just across the glass industry, but across society. Hydrogen and the use of hydrogen, biofuels and alternative fuel sources, electrical boosting in particular. There's a huge amount of research and model validation that's required in these areas. We personally don't believe from some of the research that we've carried out that there will be a single solution that fixes everyone's problems. We believe we will see hybrid fuel and potentially dynamic fuel use across furnaces. Any furnace operator will know that a gas with a changing CV, for instance, generally wreaks havoc on a production process. The reality is, as autonomy comes into furnace controls, we need a way to demonstrate and actually allow systems to learn and prove new technologies. Air, oxygen boosting and oxy-fired are all technologies utilised across the industry. We recognise that we can't do everything at once. So the main thing that we're looking at is how do we focus in on a certain area and concentrate on delivering value in a certain area, and then moving on to other areas as we go forwards. Energy efficiency and burner developments are absolutely critical. So I know you asked the question before, David, about preheat of raw materials. We recognise that heat recovery has always been an important topic for the industry. The ability to actually prove and demonstrate technologies and business cases is more than often difficult in real industry. As such, we think this is a good opportunity to actually pull some of those developments forward and offer people high temperature waste gases to prove technologies on. The furnace insulation strategy is particularly important. We have a small furnace. As such, a small furnace doesn't always have the best insulation properties. It gives off a lot of heat relative to its area. So it's important for us that we get the insulation strategy right here. That can potentially help industry. And we really have built into the fabric of our process an Industry 4 approach. It's vitally important that this furnace is not a manually controlled, go out and physically dip a level with an old metal rod. This has to be cutting edge, because this is about demonstrating technology to the industry and allowing the industry to put together business cases that really prove that the investment in these technologies brings yields, brings efficiency improvements, and lowers people's carbon footprint overall. So we're going to do a Q&A session now. If you bear me one second, I'm going to have to just slightly change my headset setup, so I'll be offline for about 1 second. But I don't know if Jan, you're there, if there's any questions that you'd like to field as well. I know you've been particularly involved in the furnace discussions as well.
Are there any questions, please?
Who's got their hand up?
A very preliminary design on the furnace at this moment in time. So.
Richard, you've got your hand up.
All right.
Sorry, Jan, are you still speaking?
I was not speaking, but I was another Richard or Robbie had a question or remark. So
Okay.
Hand come up first.
Yeah. Who you called to speak, Aston? Who's speaking?
Robbie is. You have your hand raised.
Yeah, I've got a question. Yes, please. So, is the Glass Futures planned to be operational 24/7, 365 days a year? That's to Aston, I
Not
suppose.
necessarily. It depends on the experiments we're doing. So, one of the things we're looking at for this furnace is able to switch it on and off fairly easily. So, based on the experiments we want to do or need to be done. So.
Okay. Okay, I've got another quick question as well. Then also, so how are the major decisions made between the design team in the Glass Futures design team? What's the process for that?
Could you repeat that question? Sorry. Dropped out a bit.
Yeah. How are the decisions made on the plant from the design team meetings? What's the process of the final decisions being made?
I don't think we have a process in place for that yet. So it's.
I think.
Maybe I still know that.
Yeah. I am. Can you hear me now?
Yeah.
Sorry. 2021, and I had I had an error with my headset. I think one of the the philosophy that's coming out of these design sessions has been it's been really positive to see a good collaboration overall. Our current process has been to identify what all of our potential options and solutions are. Generally, at the moment, there is we've not come to any crossroad decision points, but we do recognise those coming forwards over the course of the next coming months. So, Glass Futures has a technical steering committee, which has a small representation from our key members on it, and we see that as an important group of people to have in the background to ensure that overall the membership are happy with the decisions and processes that are made. You know, we can't be everything to everybody, but what we can do is make sure we cover a large amount of our member base in terms of the value that we need to deliver. Richard, is your hand up for a further comment?
Yes, if you don't mind. Yes, please. I'd like to tie in the batch and the furnace, if I may, for people on the call. I'm with Guardian Glass, if people don't know. And Matthew, I'd just like to tie in again with one of the questions you asked about pull rate. Certainly, the strategy of Glass Futures is based on fuel switching, process control, Industry 4, and raw material development, right? We're interested in process control and raw material development. So we want a stable furnace so that we can actually test out our raw materials. So we're not really bothered about commonality. We don't have a container furnace with a throat, and we don't have oxy-fired furnace. But if this turns out to be a small furnace that's oxy-fired and very stable, it will allow us to do things that we can't do in the lab. Lab melting, as we all know, in crucibles is vertical melting. It's probably more similar to electric melting than it is to what we do on our floats. And this actually gives us an opportunity to have the combination of vertical and horizontal melting, which will allow us to test some of the raw materials, some of the compositions, and some of the batch pre-treatments that you can only get a hint at in lab work. So that's why we want this kind of furnace. So it all ties in together. I just wanted to make that point, Aston.
That's perfect. Thank you. I don't know if there's any further questions from across the group. The questions I suppose I wanted to pose to the wider group, and it may be that people choose to answer them outside of this overall, is that I think there's a lot of projects that are out there, especially in relation to the furnace area, that have ultimately been shelved because there wasn't able to be a demonstration platform to actually prove these technologies, and someone wasn't quite willing to take that initial jump and see if they work on their own furnace. And I think the key element for Glass Futures is to make sure that we really reach out and identify what those are, and make sure people can actually come forward and discuss those with us. You know, and ultimately this is all about linking up that supply chain through to manufacturers and supporting the glass industry to become a more competitive and more economically successful industry than it currently is. So, is there any further questions at all across the group? Stuart, I can see you've got your hand up.
Yeah, you're saying that you're going to build a conventional one first, which I think is disappointing because we already know how an existing furnace works. But what is the process going forward? After you build the first one and you want to incorporate radical ideas, will you use the same person that built it the first one to do that, or will that be open to tender again?
Yeah, I think it's a good question, Stuart. I think an important part of the as there's a heavy amount of public funding for Glass Futures, and as we are a open research and technology organisation, what's important is that for a lot of our tender processes, they will be under the OJEU process, so the Official Journal of the European Union. As such, as we go forward, what we don't envisage is having a single supply contract with any one individual organisation, that no matter what happens from this point onwards, they will supply X, Y, and Z, especially for contracts over a certain amount. And those amounts are posted online across a number of different platforms. But for a significant amount of contracts, you know, they are subject to public procurement rules overall. So everyone has a fair and open opportunity to be part of that process. And we think that's an important aspect of, ensuring that Glass Futures maintains that open and transparency and, allows it to really serve an industry overall.
I'm concerned about the 3 to 5 years life too. But it seems to me that if you're thinking 3 to 5 with a conventional furnace, you're awfully slow in doing what you can do. Why are we so conservative? Why aren't we looking at that first campaign being, 2 years?
Could I jump in on that, Aston?
Yeah, please do.
Hi, Stuart. We've not made any final decisions, as far as I know, on this furnace design, and Jan made reference to the fact that this furnace could be switched on and off for mini campaigns, and so the refractories that we use for below glass and above glass could be very different to what's used. That's why I'm not sure I like the idea of commonality. It may be that we don't want AZS blocks below glass because clay is good enough for what we're going to do, and it's better for draining and filling. And it may be that we have a different superstructure to what's common. So this is why we want to invite people in to say, okay, what do you think? What kind of experiments do you think we should do, and how does that influence the design? So great question that you raise.
Thank you.
It's okay. So any further questions at all? Any input, comments before I move on? Okay. I'll move through then. So to discuss the refractories aspect, and this is an important part of any of that, and I know Richard, you've just picked up on it very well there in terms of the specification side. And I think maybe this in particular, Stuart, is an area where, to say a conventional furnace, I suppose it's about understanding what features might it have that maintain it as being seen as a conventional furnace for glass melting stability versus features that are very unusual that ultimately don't impact its ability to perform industrial fuel switching trials or raw material trials, but that actually give you an opportunity to do some other developments and other advancements on the furnace as well. And I think a personal comment, even what Glass Futures, if Glass Futures does build a conventional furnace, I think it would probably still be looked at as very unconventional for a majority of the industry, maybe just a conventional from the viewpoint of Glass Futures. And in particular, this is where we really see a large supply chain opportunity in refractories. One of the things that we are looking at really is about the design of the experiments that we run with relation to fuels and raw materials. But we recognise it as a huge opportunity here to actually, run some real in situ refractory tests. And I know this is just a very light sketch form at the moment, but what we wanted to try and capture in this is some of the things that we've got written down at the moment in terms of, where are the experimental opportunities that exist for refractory developments. In particular, there's one main design feature that we're currently looking at on the furnace, which is significantly different. And this is to essentially have a what we're calling a refractory testing pocket. And we've called it an alcove before, but alcove is used by the container industry for different fore-off, so we're not allowed to use alcove. But this is a refractory testing pocket, essentially, is what we determine it as. So this is envisaged as being an area of the furnace where we can have a water-cooled dam to close that area off and drain it out. It also provides us with a fixed drain point on the furnace, but the opportunity to actually drop refractories in to lift any water jacket off and then run in situ glass contact refractory tests in that area. One of the things we've discussed is having a stirrer in to ensure we get good circulation, potentially a bubbler to make sure it keeps running, maybe even a burner just to make sure it doesn't get too cold. But this in particular is something we see as a really good opportunity to actually have live glass contact testing inside the furnace. Not just that area as well, but obviously on the superstructure in terms of burner positions, burner blocks and different refractory developments in that area. The crown in particular, we know there's a number of different design philosophies and approaches as to what material do we use. Does it have to be the same material throughout the whole area? Do we have different floating sections where we do side-by-side tests of different materials? The reality is Glass Futures is not a refractory developer or supplier. What we're really looking for here is an opportunity to take us away from just ordering something per a specification to deliver what we need, but actually recognizing that, you know, there's a chance here for an industry to actually develop something at a significantly more rapid rate in an environment that's very close to the industry it serves, in a way that can actually get demonstrable results and prove what the properties of their refractories actually look like. We think mouldings and compositions being tested in a live situation is a big possibility. Ultimately, we don't want a glass leak. But what we do recognise is that if we're testing a refractory out and we're a bit unsure or a bit concerned about it, we can put things in place such that if there is an issue, we can, you know, shut things down and take glass level down, remove that contact area, etc. You know, we are not going to be at the behest of having to get that furnace up and running in the space of 3 hours and doing things just to patch it and fix it. So there's a really good opportunity here to actually try things that aren't necessarily able to be tried in that manufacturing environment. And Richard, I know you picked up on it, but in particular, the selection of the refractory is an interesting, you know, ultimately we're a research and development facility. We have a budget. This is all about choosing something that is economically the right choice and the right specification combined. What we recognise is that there are a number of different philosophies and approaches we can take. We don't have a fixed one at the moment. Richard, you've got your hand up. I'm quite happy for you to comment on that.
Yeah, I'm sorry. Just so that people in the audience know, I am working as part of Glass Futures, so I'm not just using a cheap ticket to get to the front of the line all the time. I think this is a good example of participation is really a good thing to do, because this alcove is a guardian idea from the very first discussions of Glass Futures, and we were pushing for this and being able to test refractories in exhaust. Other people agree with that philosophy, and so it's become embedded as part of the design. So anybody who's interested in testing something out, Stuart, you know, more participation is always welcome. So
in that case, you should put an electric electrode in it to stir the glass, not a bloody mechanical stirrer.
We're always open to taking samples of electrodes or other pieces of kit, Stuart. So we'll put that on the list.
How about a plasma gas bubbler instead?
That's with my Glass Futures hat. That's with my Glass Futures hat on, folks. Right.
Okay. So in particular in this area, the key things that we are looking at is, you know, we've talked a lot about the ability to actually change these refractories out easily on the furnace. You know, ultimately this is a training and development and research platform. We want to make conditions that make it easier to actually carry out these trials. You know, the ability to easily remove parts of the superstructure, as an example, is not something you design in traditional furnace. You know, people don't plan to pull breast walls out of furnaces. The reality is we have an opportunity here to actually design that in at the early stage. Do we need to? Is there a desire for it? Is it a valuable thing to design in? You know, we're really looking to make sure that anywhere we are going to utilize expenditure on the furnace, it's utilized because there is a clear value to the marketplace. It might help a supplier trial a new technology that hasn't been trialed before, that may well increase its use, might make the industry more efficient or more economic. So in particular, when you look at the options around the furnace and you start to think about it, there is a lot of areas to play with. You know, batch carryover is a really interesting piece. People don't want to use their own furnace as a batch carryover testing vehicle. More often than not, you know, it's not something that people want. But what we can do here is actually find a way to explore these opportunities and actually run some risks to see what these impacts are like on refractories. In particular, the thing that we're interested in and we are investigating in part of our other program is the atmospheres and the atmospheric effects of different fuels and different compositions onto refractories. So again, you know, this really is an opportunity to push the boundaries out in terms of understanding. So got a Q&A session out. I notice you've got your hand up, Richard. Is that an old hand or?
If it's mine, it is an old hand, yeah. Not intended.
It's okay. So I think the key things I wanted to point out in this area is, the demonstrations themselves will begin in 2023. Has any refractory supplier knows, or anyone involved in that refractory supply chain, lead times on refractories aren't like going out and just buying a brick for your house. These are long lead time items. If you work backwards from that, the design that's involved within them as well, the course of the next year really is going to be the time where any opportunities that are going to be designed into the fabric of this facility are going to be designed in. So we think it's really important to understand, what work do we need to do now, what things are put forward to help us understand it. Glass contact refractories without a proven glass record, it's a rhetorical question, this. I know that no manufacturer in the world will put something in if they think it's going to give them a glass leak, but I'm sure there's plenty of suppliers that will be confident their material is not going to do it. It's just about trying to overcome these hurdles and barriers. And I suppose a question for me to just leave in people's minds, because it has come up a lot about furnace campaign length, is the industry is driven towards large furnaces and long campaign lengths. Ultimately, refractory replacements, and the process of rebuilding furnaces is a huge part of this cost. We think there's an opportunity here to actually start challenging that status quo, and that by doing more developments in refractories in live settings, we might be able to help to actually change that philosophy as well. So, or at least challenge that philosophy. Animesh, you've got your hand up.
My question is to our distinguished colleagues. Is there an ideal refractory which is already there, or do we need to discover that minimizes the disruption in furnace operation? So question can be to any colleagues who are involved in furnace design, glass processing, etc.
Anyone like to field the question? Stuart, you've got your hand up.
We already know the perfect refractory that will last forever, and that's broken glass, but we never use that. So that was the first comment. The other comment is that the existing refractory AZS is very good. It's just that we make it too thick. If we had it much thinner, we get shorter lives. We'd still get guarantee of no glass leak and very little exudation or stones. So the problem is that we build them for 20 years and not build them for 5, which is how far ahead we can see the market is, and that's what we should be doing. So everybody knows my position on that.
What is AZS? Alumina, zirconia, silica?
Yeah, alumina, zirconia, silica, fused cast.
Okay.
I'm going to just to open the conversation out. So Spooner, SRI, I see you've got your hand up.
Hi, yeah. I was just wondering, with the pilot facility investment, you talked a lot about the potential in terms of using that, but is there a fund or do you already have a suite of equipment for characterizing and analyzing the material that you will be making?
So I think key to Glass Futures' approach is understanding that as a research and technology organisation, our main focus is on trying to bridge the gap between academia and industry. So in particular for characterization, analytics, etc., we really aim to utilise the network of experience and equipment that exists to try and really promote the collaboration across the industry overall. So our objective is to demonstrate in a hands-on fashion, and then to use academic excellence through our academic network and different academic partners to actually bring that academic knowledge in, but then also to tie in with industry to actually see, this is the industry's perspective, and this is how this might actually help us as we go on. So I don't know, Richard, if you've got a comment on that as well, and then Matthew, I'll go to you afterwards.
Okay. Yeah, one comment, Animesh, thanks for the question. I mean, I was always told, when you a mental model for glass making, we're boiling water in a kettle that's made of ice. The thing's going to dissolve and all that. But so ideal refractory? No, I don't think so. I don't know if we want it, because part of what Glass Futures should be doing is not just challenging technology, but challenging some of the business paradigms, as Aston alluded to. We're looking to get maximum dollar efficiency for making our glass, and in some ways, maybe there is some benefit in exploring smaller, shorter life furnaces. I don't know. I mean, we don't know what technology is out there, but right now we're continuing to perpetuate the role of technology to fulfill these business paradigms that we may be challenging. So I think there's a lot going to go on in St Helens once we start it rolling. Thanks, Aston.
Okay, and Matthew?
I was just wondering the sort of whether you would have pollution control and emissions monitoring, and how you anticipate that fitting in with your application for a permit.
Yeah, so yeah, I can answer that. So obviously, one of the things that was critical when we looked at these areas was, we mustn't go out into the marketplace and talk about the advancement of technology and not have the best available technology that exists. So our current thought process is to look at the ceramic filtration technologies. Obviously, what's important to us is that while we are carrying out research, we really need to have the minimum amount of impact as possible overall. So as part of that process, yes, there's a full abatement equipment planned with ceramic filtration, which is best available technology. So to really get the cutting edge that's available in terms of pollution control. We do think there are some advancement and development opportunities in that area as well. Obviously, as you might imagine, it's difficult to specify an abatement equipment without having this is the furnace features and outputs and other things that are expected from different areas. So obviously, in terms of working through the process, that is going to come as we get more into the detail of the way that the furnace is actually going to look and what it might produce. So
okay,
thank you. Is there any other questions at all from anybody before I sort of move through and close off the session? Can't see any hands up. Scroll back. Okay. In that case, I'll start drawing things to a close overall. I think an important aspect that we'd really like to leave as a lasting message as part of this process in everyone's mind is that the timelines are an important piece to understand. More often than not, when you look at development like this and you hear the headline that this is going to open in 2023, and sometimes it's easy to think that's 2 years away. So what does that leave? What does that leave? What does that mean for me now and over the course of the the next year? I think hopefully what we've been able to do today is to show that this design process, this specification process, and understanding what will occur in this facility in 2 years' time is happening now. And I think it's quite often easy to forget that when you see that headline timeline figure of 2023. The design, the specification, the procurement is all happening over the course of this year. And as such, we think it is actually vitally important for people to join Glass Futures and to join our smaller, more detailed design sessions and actually start running through the mechanics of these pieces. In particular, because those first major projects that we think are going to deliver real value to our members are being formed over the course of this year. What we've done today is talked about raw materials in the batch plant, the furnace, and then the refractories in relation to those in particular. We've got 2 more sessions planned of this current format. This is the first time we've opened up in a way like this. So what we wanted to do is put 3 sessions in. The next one we'll be looking at digitization, forming and quality. So hot end, cold end. What is the production side of the facility going to look like, and how might that tie in for development opportunities? We then want to talk a bit more about people, skills and collaboration on the 31st of March. We'll obviously be promoting these out and putting these out, but I think the reason we decided to cut them up into these areas is because we really see that these are the big opportunity areas that do have different supply chains involved overall. So we hope you've enjoyed today's session. I know it's certainly been a pleasure from my side, and I'll hand over to Robbie just to run through any other pieces and just say thank you.
Yes, there's just been one last question asked them from Stephen Bedson. I don't know if you want to ask that question out loud, Stephen, or you want me to ask it.
I'm quite happy to.
No, I'll ask it. It's fine. Just listening to the end of the presentation, it looks like you might cover it in subsequent sessions. So I manage the neat engagement service contract for St Helens, and basically looking at routes to improve social mobility for the young people of the town. Just wondering what employment opportunities and entry routes will be available to young people in this town and Liverpool City region. Obviously, it's quite a big question. If it's going to be covered in subsequent sessions, that's fine. But can you give us a little snippet?
Yeah, of course I can. So I think if we talk a bit about the wider industry impacts overall, and like I said, we will go into this in detail in March, but one thing that has become very evident across an industry that has typically shrunk its workforce in the UK is that an ever more specialised workforce that is required is actually pulling from an even smaller talent pool overall. And the glass industry and the skills in relation to the glass industry really are an international and global affair. We really see Glass Futures as a place where different competitive organisations with common interest in an industry can actually come and recruit and effectively train their own staff, but also pull other staff members into, these large international opportunities. And the practical hands-on experience of glassmaking is one that is, only available to those that work in industries that are generally in certain areas. So to break into it as an industry can be quite difficult overall. We really think that Glass Futures is going to provide a significantly better opportunity for people to actually access a global marketplace of what is a high played, highly skilled and vitally important material for the whole of civilization. So
thank you.
Not a problem, Stephen. Thank you for the question.
Thanks, Stephen. Yeah, just we can bring the session to an end now. I just wanted to echo what I said earlier. I'll send the slides out to everyone, all attendees. If you do think of any further questions in the meantime, the email address is on the slide in front of you now. And I'll make sure invites are sent to everyone for the 2 further sessions that we've got booked in. But unless there's anything else from you, Aston or Richard Katz, I think we can bring the session to a close. No?
I can just say, Richard Katz here, just to say thank you very much indeed, everybody, for joining us. And I hope that it will give you some food for thought. We really do want to build this for you, the glass industry and the supply chain. And we need your input to understand what it is that you would like this to do for you. It's, I repeat, funded very substantially by government, and we must take advantage of the opportunity which is now in front of us. But thank you all for joining us and look forward to seeing you next time round.
Yeah, thanks everyone.
Thank you.
Thanks everybody. Stay safe.
Thank
and well.
you. Thank you. Bye. Thank you.
Thank you very much.
Thank you.
Thank you. Bye.